one part of the test case of our test cases is input data. The input part of this test case is the array with 3 elements. Another part of the test case is expected result. The expected result is 1. And the actual result we have seen is actually 1. So in this case, we don't feel a failure in execution of this method because the actual result and the expected result is the same. But what about error? Are we experience an error state in execution? Yes. Yes. In the first round of execution, the for statement, the internal I variable should be set to 0, not 1. So the first statement we pass in this execution is an incorrect state, internal state. So we have experienced an error state in this execution, but this error state does not lead to software failure because its incorrect internal variable do not affect the final state of the execution. The final state of the execution sets I to value 2, index 12. The array, this is correct, and the value of count also correct. So the the first error state do not propagate through the execution path and do not affect the final state of this method. So this error state doesn't cause a software failure. We have no software failure in this test case. But look at this test case. How about this test case? This test case includes an input data, an input array with 3 elements, just the elements located in the first test case, but the order of them are changed. In the new test case, we have a 0 element in the first position of the array. So as we've seen, the first position of this of the array is not checked by the for loop, and the internal state and the first error state would be published, would be propagate across the execution path. The result of this error states would be propagated during the execution of this for loop, because in the first round of running for loop, the count should be set to 1, but this isn't done because the for loop starts at position 1 and the first element is not checked. So this error propagates during the running to the variable code. The error state affects the count variable, affect the final value setting in the count variable. So this causes a software failure. the final return value is 0 instead of 1. So we see actual value as 0 is not the same as expected. One. So we feel the software failure count is 0 at the return statement. So we summarize this problem. Not all executions of a program shows failures. In software testing, we try to design tests that could show failures. Good tests are those that can show failures. Tests that are not that could not show failures aren't very important. So we try to design tests that could show failures. But for doing this important work, we should learn a lot of rules, a lot of principles in software failures, which is learned to you in this course. Okay. The other term that is using informally in some text, some informal text and informal speakings is the term bug. The term bug sometimes used instead of fault, sometimes used instead of error, sometimes means failures in informally speaking or informally text that's published daily in software testing concepts. This term are not meaningful in engineering or technical texts in this area, and this class will try to use words that have precise, defined, and ambiguous meanings, such as fault, error, and failure. And we don't use bug in this course or in this textbook or in other textbooks, but there are some historical documents, such as documentations of Thomas Edison and other scientists that uses bug, but today we use just fault, error, and failure with the mentioned meanings in previous slides. And in the next slide, we see some spectacular software failures in recently decades of software products, such as NASA Mars lander, Track 25 radiation machines, and Ariane 5 explosion. For example, note that in Track 25 radiation machine, poor testing safety critical software causes to kill 3 patients at the first usage of it. This is because of a software, just because of software failure. A software failure in its controller, in its embedded control application. Or in NASA later, also the software failure caused crashes due to a unit integration fault. The software failure in Ariane 5 led to an explosion just after flying because of a bad digit conversion. and causes a $320 million loss. There are several examples of this type in the literature. You can search and study them, what happened in recent years because of software failures. So we say that we need our software to be dependable, and dependability testing is one way to assess dependability. You should note that testing could not guarantee that a software product is fault-free. This is important. You should note that testing could not guarantee that a software product is fault-free, but it tries to find more faults in software product. It gives us more confidence about the product. This is one of the many tools, many approaches that are used for assess dependability. As another example of the catastrophe happening by software failure is the Northeast blackout in 2003 in America and Canada, which causes 508 generating units and 256 power plants shut down, and this affected the life of 10 million people in Ontario and 20 million people in 8 US states. And the financial loss is about $6 billion. When they checked the root cause of this happening, they received that a software failure is happening in the alarm system in the energy management system. And this blackout continued in some parts of these regions for about a week. So this is a bad catastrophe. In the literature, there are several reports that show the cost of software failures in recent decades. Some of them reported by the NIST Institute, some of them reported by Forbes and McAfee and etc. You can search these documentations, and you can study these reports and see what's happening in software products recently. Also, this slide shows some of the software failures that causes more vital happening and a large monetary losses in all over the world due to these failures. So software testers try to find faults before the faults find users. This is an important sentence in this slide. Software testers, what is the work of software testers? What is the responsibility of software testers? Software testers try to find faults before the faults find users. In these cases, faults found its users. So we summarize this talk about the importance of software testing in 21st century. As we know, there are more safety critical systems in our world, and real-time softwares, the embedded softwares, has a unique role in our life. And you know that enterprise applications today is more bigger than ever and has more users, and free software increases our expectation from the software products, and security is a notable challenge in software products to the reliability, other quality attributes such as maintainability, testability, availability, and scalability is some of the attributes that should be guaranteed by today's software product. But for guarantee these attributes, we should learn some rules, some fundamentals, and we should learn software testing in an engineering manner in our academic education programs. So this course continued with this goal. I hope at the end of the course we got my goals, and you will be satisfaction for this course. But what about cost of not testing? Can you tell me what is the cost of not testing? Also, you have seen in the previous slides some of excuse me for pausing the recording, and in this slide we say about what is the cost of not testing. In the first statement, it's correctly poor program manager might say testing is too expensive, and they plan for not testing. Actually, testing is the most time-consuming and expensive part of software development. This is true, but as we saw in previous slide, not testing is even more expensive than testing. So we should testing enough our software product to have an acceptable quality and prevent some catastrophe happening. If we have too little testing effort at early stages of software development, the cost of testing actually increases. We talk about this sentence in the next slide by some reports of one of the known institute at Carnegie Mellon University. And the last point is planning for testing after development prohibitively expensive. This is just this is true also, and I will talk about this in the next slide. Look at the chart of the mentioned report. This chart is reported by Software Engineering Institute of Carnegie Mellon University. This is a real research. This is the result of real research. This funding is could be dependable, and we talk about the last 2 points in the previous slide. Please note that in this chart the yellow bars show fault origins. As you see in this chart, approximately almost of software faults originate from the 3 first stage of software development life cycle, such as requirement analysis stage, or design phase, or implementation phase. So you should note that if we could prevent faults in this stage, in this first stage, we don't have side effect in the later stage of software development life cycle and in post deployment phase. So please note the fault detection capability of software engineers is in different phases of software development process. The green bar shows the fault detection, the amount of fault detection in each stage of software development. At every stage we could detect some faults in our software product, but the faults that is detected after deployment of software is very costly faults. For this, you should see the red bars. The red bar shows the unit cost of the faults detected at each stage. Faults detected in the post-development stage is more costly than the faults detected in previous stages. So we should try to detect faults in phases previous the deployment of the final program. Especially, we should try to detect faults in the first 3 stages, because the faults detected in these first 3 stages has a little cost and could be neglected in the cost of overall cost of the project. So in software testing, we try to design test cases as early as possible in software development life cycle, and we try to do the testing as soon as possible. We summarize our talking in this lecture, this slide. The first question and the title of the chapter is why do we test software? At this point, all of you know why we do the software testing. A tester's goal is to eliminate faults as early as possible, and this could improve the quality of our software product. This could reduce the cost of our projects and preserve customer satisfaction. I finish this lecture at this slide, and this is the last slide of our chapter, our first chapter. I hope this lecture would be proper enough for you. I wish you have good days. Goodbye. See you next session.